Hello everyone, I'm going to show you a car driving game, a project completely developed with WebGL version 2. As you can see, we will have on the center of the screen the play button to start the game. On the left corner will be shown the number of coins we have collected so far, as well as the fuel meter. This shows us how much fuel we have left to keep on going. Once the fuel goes to zero, the game restarts. The point of the game is to collect as much coins as you can before the fuel runs out. On the right corner, we have some more detailed controls. We can pause the game as we please. In addition, we can manually control the fog and the visibility by dragging on this slide bar. We can also display the collide boxes for some of the models available. And finally, we can turn off the car's front lights. They are on by default. The sun symbol shows us what time it is. Lighting and visibility conditions change depending on the time of the day. Usually, it will be harder to see at night. Let's run the project. Some basic control movements for the player include W key to tilt the car up, S key to tilt the car down. With this key, we can move the car up and down. A key to roll the car to the right. D key will do the opposite. Some basic controls for the camera include Q for zoom out, E for zoom in. Z, X, and C will rotate the camera around. As the time of the day goes to the night, we can choose to turn off our front lights or to turn them back on. We see that we are running out of fuel, so we must hurry to get back some. Fuel usually spawns at the side of the trees, near the river. We restart the game because we ran out of fuel.
Okay, so now we'll explore how we achieve the effect on the game. Yeah, first let's talk about the models. We load models from GLTF file. Here we have some folder contains the models. Here we have the model for the tree, the fuel, the skybox, and the car. We implemented a load GLTF function which read the content of the GLTF.json file. It's in JSON format, and will process the scene. Process is each node, and each node will link to a mesh. And yeah, several objects like trees will share the same mesh, so we'll try to use a mesh storage here to store the mesh so that we can reuse it. Yeah, we also have a prefab store here where we store the proto of the object, like the node we parsed from the GLTF file, and we store here initially. And yeah, whenever we need to create an instance of the object, we get it here and we clone it using the copy constructor. Yeah, it is useful to construct trees, fuels, tanks, and coins. On our GLTF file, we also use the physical-based rendering, like including the roughness and including the texture for metallic and roughness of the material, like this here, and also an emissive texture for the light of the car. Yeah, and here the texture for the base color of the car, and we also use the normal texture. Okay, so we also use GPU instancing. So you know that many objects like trees and things use the same vertex array object to store the vertices, the normals, the textures. Yeah, they share the same with only different, yeah, like word matrices. So we use the GPU instancing to optimize the rendering calls by passing the VAO object only once and then pass all the word matrices as in a buffer. Right here we buy the VAO that contains all the vertices information and all the normals and texture coordinate. Yeah, then we pass the word matrices into a buffer. Yeah, and we can access that on in the shader later, and it will interpret each as an instance. That will dramatically improve the performance when rendering a lot of trees. Also, as you have noticed that we implemented a skybox sphere panorama effect on the game. So here it is. We load the skybox as a sphere object with an emissive texture, and we set the depth mask to false and no cold face. Yeah, so the skybox is actually a normal object with no depth, and yeah, and an immersive texture. Now let's have a look at the shader. Here the vertex shader from normal object will have the, here is the word 0, 1, 2, 3 is four column of the word matrices that we passed before. Yeah, so each four of these will represent a word matrix for an object, an instance. So it will construct the matrix, word matrix, and calculate the position and the normal. And for the fragment shader, will have five lines up to five light sources here, with each having an ambient, diffuse, specular, color, position, direction, cutoff, and outer cutoff is for the point line. Okay, so here is all the texture that we use. Here's the base color, the material roughness and metallic texture, the emissive texture, the normal texture, and all the fresh texture will come together with a factor so that it will control how much the texture will affect the color. We also have the variable for controlling the fog, like the color fog, the neon for parameter. Okay, so we'll use the font shading model here to calculate the light effect here with the ambient, diffuse, and specular. Okay, so here we'll load all the texture and apply it here in the calculating the light part. And yeah, when we got the final color, we'll multiply it, the base color with light. Yeah, then we'll calculate the fog effect by using the smooth step and mix function of the OpenGL. Then the outer color will be blurred with the emissive. This is to make the emissives stand out from the fog, like the light of the car will glow in fog condition. Okay, so finally when we load the screen, there's a lot of trees, and yeah, we started at one object on the prefab store, and it will be cloned when we render the screen. And yeah, and we also utilize the GPU instancing to duplicate those trees with only one cone to the GPU. That's also happened with the fuel in the coins. And yeah, we can visualize the collide box here, so that you can see that each object can collide with each other. So if our box collide with the trees here, we'll reload the screen and restart the game. And yeah, when we change the into fog condition, yeah, the emissive light will go up and below, and we can navigate our car. And if we choose to turn it off, yeah, it's harder to navigate in such condition. Yeah, and that's all for our project. Detailed information will be provided in the project report, so you can see more about our user manual and functions there, and for detailed implementation. Okay, thank you for watching the video, and see you later.